All right, let's talk C++. If you've been in the trenches, you've definitely hit this classic problem. You need to store a bunch of unique items, but which container do you reach for? Well, today, we're putting two of the standard library's heavyweights head-to-head, std set versus std unordered set.
Okay, so picture this. You've got a pile of unique things. Maybe it's a list of usernames, product IDs, song titles, whatever. Now, do you need them sorted, or do you just need to know if something's in that pile, like instantly? The choice you make right here can have a huge impact on how your program performs. So, let's bring our contenders into the ring.
In one corner, we have the incredibly meticulous standard set, and in the other corner, the lightning-fast standard unordered set. Now, both of these are built to do one thing really well, store unique elements. But, and this is the key, they go about it in completely different ways.
To make this easy, let's give them some personalities. Think of standard set as the organizer. It is absolutely obsessed with order. Every single thing you put in, it carefully places it to keep the whole collection perfectly sorted all the time. Now, on the other hand, standard unordered set is the sprinter. It couldn't care less about order. Its one and only goal in life is raw speed, finding, adding, and getting rid of things as fast as humanly possible.
So, to really get when to use each one, we kinda need to pop the hood and see what's making them tick. Their internal data structures, that's the real secret to their strengths and their weaknesses.
The organizer standard set is powered by something called a red-black tree. Now, don't let the name intimidate you. The important thing to know is that it's a super clever tree structure that automatically keeps itself balanced. What this guarantees is that your elements are always in sorted order. It also means that finding or adding something is reliably fast, but not quite instantaneous.
The sprinter, standard unordered set, takes a totally different path. It uses hashing. It takes your element, runs it through a function to get a special number, a hash, and then uses that number to drop the element into a specific bucket. It's like having this magical filing system where you know exactly which drawer to open without ever having to search. The result? Absolutely blazing fast lookups.
Okay, so this slide, this is the whole ballgame right here. std set gives you that guaranteed order, but its average speed is logarithmic, or O of log n. Now, that's still really fast, but it means it gets a tiny bit slower as you add more and more items. std unordered set, on the other hand, gives you zero guarantees about order, but its average speed is constant time, O of 1. This means it takes pretty much the same amount of time to find an item, whether you have 10 elements or 10 million. And that, right there, is the core trade-off: order versus speed.
Theory's great and all, but let's see how this actually plays out. We're going to look at a couple of programming challenges inspired by the Kattis platform, just to see which set comes out on top in different situations.
So first up, imagine you're building a system for a radio station. You just need a list of every unique song played today. This list could get huge, and you need to be able to check really fast if a song has already been played. So does the order of the songs matter here? Nope, not one bit.
For this job, it's a no-brainer. The sprinter is our clear champion. std unordered set is the perfect tool. All we're doing is checking for existence, over and over. That 001 average lookup time means our system stays super snappy, no matter how long the playlist gets. Using std set here would just be adding unnecessary work, making your program feel a little sluggish for absolutely no benefit.
All right, now for a totally different challenge. Let's say we're calculating all the possible places a chess knight can go on a board. And for our algorithm to work right, or maybe just to have clean, predictable output, we need to process these unique positions in a specific, sorted order.
Then here, the organizer, stead set, takes the crown, easy. The second you hear that requirement for sorted data, your brain should just light up with stead set. It does all the hard work of sorting for us, automatically. Trying to use an unordered set here wouldn't just be inefficient, it could actually cause bugs if some other part of your code assumes that the data is in order. Stead set guarantees it's correct.
Okay, so we've seen the theory, we've seen them in action. Let's just boil all of this down into a super simple guide you can use every single time you need to store some unique stuff.
It really is this easy. Step 1, you ask yourself one single critical question. Do I absolutely need this data to be sorted? If the answer is yes, for any reason at all, you can stop right there. Your champion is std set. Now, step 2, if the answer to that question is no, then your priority should pretty much always be speed. And in that case, your champion is std unordered set. That's it. It's that simple.
So the final verdict, one last time. If order is a feature, something you actually need, use STD set. If raw performance is what you're after and order is irrelevant, STD unordered set is your champion. It's all about matching the right tool to the right job.
So with all this in mind, I want you to take a look at the code you're working on right now. Seriously, are you using a vector and then sorting it just to find unique elements? Are you using an STD set where the order doesn't even matter? You know, choosing the right tool isn't just some academic exercise. It's what separates good code from great code. So think about it. Where could this simple choice make your code better?